Okay, so today we're going to go over the study guide for our Unit 2 exam. So starting with question 1, it says trapezoid PQRS is resized by a scale factor of 3/2 about the origin and translated 5 units up. What are coordinates of P prime? So first I need to find the coordinate of P. When I look at P, I start at the origin and I go to the left 2 times, 1, 2. And I go down 1, 2. So that's the point for P. P is -2, -2. Then it says I'm going to resize it by a scale factor of 3/2, which means both of these numbers I want to multiply by 3/2. So since they both are the same, I'm going to do -2 over 1 times 3/2. That gives me -6/2. Which equals -3. So that means both of these numbers for P, when it's resized by the scale factor, that will give me -3, -3. But then it says you want to translate it, which is to slide it 5 units up. So going up means it's only going to affect the y coordinate. So if I'm going to write this in coordinate notation, that will be y plus 5. Because y is -3, I'm going to add 5 to -3. So that's -3 plus 5 for the y coordinate only. And that gives me P prime, which would be -3, +2. Okay? So this is your final answer here. All right. So the next question says triangle XYZ is located at X, and they give you the coordinates, and it say graph and list the coordinates after a dilation of a scale factor of 1/2 and a rotation of 180 degrees. Well, for scale factors of half, that means each of these are going to be halving because I'm dividing them both by 2. So -8 divided by 2. 2 divided by 2. Then y is -4 divided by 2. 2 divided by 2. And then z is -8 divided by 2 and 8 divided by 2. Okay, so that gives me for x prime, the new one, okay, that's going to give me -4, 1. Y prime give me -2, 1. And z prime will be -4, 4. That's the first part. That's the dilation of a scale factor by 1/2. Then it says rotate 180 degrees. Well, I know if I rotated 180 degrees, the coordinates stay in the same position. So if I rotate 180 degrees, we're going to look at this part right here. That rule says you take the original coordinates, keep them in the same position, and take the opposite for each, right? So now that's going to make the opposite of each one of these. So I'm going to write that in the coordinates. So that's going to give me +4, -1, +2, -1, and +4, -4. Okay? So it says you're going to graph it. So now I'm going to graph both points. So I'm going to graph the first one, which is 4, -1. And that's x prime. And then 2, -1, which is y prime. And 4, -4, which is z prime. And just connect your vertices because that's going to be a triangle. That's our image. So our pre-image is -8, 2. So go to -8 up 2. And that's x. -4, 2. That's y. And -8, +8 is all the way up here, which is z. So then you connect those. And if you notice, if I'm rotating 180 degrees, it should move 2 quadrants, which it did. No matter which direction, whether I'm going clockwise or counterclockwise, it's still moving 2 quadrants, okay? I know that it is a reduction because I'm going from a larger figure to a smaller figure, and my scale factor is less than 1, okay? Let's look at number 3. Number 3 says you have 2 triangles shown on a grid. Describe the sequence of transformation that verify the proof, okay? So I know that if I look here, it's going from ABC to DEF, and I know that it's moving. I'm going to label this. This is 12, 3, 6, 9. It's moving this direction, which is clockwise. So I have a clockwise rotation here. Okay. I also want to pick 2 points. So I know if it's turning clockwise rotation, that B and E is in the same position. Also, the order in which they're written. So B and E are in the same position. So I'm going to just pick those 2 for now. So I'm going to look at point B as my pre-image and point E as my image. So I'm going to write that order pair. That's -2, +3 for B. And for E, I have +6, +4. Okay. Now, first off, I know that I actually did a rotation, right? I know I rotated clockwise. Because I rotated clockwise, you know the rule for a clockwise rotation is, what do? We take the X and Y coordinate and it flip-flop positions, okay? Then we see, okay, where it started at negative, positive, and when it gets here, they both are positive, right? So here it starts at negative, positive, and then here they both become positive, which means you're going to take the opposite of the second coordinate, okay? So you can also look at the quadrant and see that when I move it, they both land positive here. So once you actually write both of the coordinates, you know, hey, it has to be positive, okay? Because I'm going from a smaller figure to a larger figure, you know I have an enlargement. So if I take my original coordinate B and I flip-flop them, so here's B and here's B prime, because they both are positive, right? They're in quadrant 1. And now I want to find the scale factor, okay? Scale factor, I take my image, which is 6, over my pre-image, which is 3. So the scale factor is 2, okay? So it said describe the sequence of transformation. Sequence of transformation says I have a 90 degrees clockwise rotation about the origin, and a dilation with the scale factor of 2. Okay? All right, let's look at the next one. Problem number 4. Okay? When I look at problem number 4, it says a transformation is applied to ABC form DEF, which is not shown. Then a transformation is applied from DEF to GHJ. Okay? So it said describe the transformation applied from ABC to DEF. First of all, it's not shown, but I know that this is a reflection, okay? Because they're mirror images of each other. So I want to first reflect this and make DEF. So this is 1 unit, 2 units away. So this is 2 units away. Okay. And I know that B is in the same position as E. So this has to be E right here. Okay. Then it says here is 4 units away from the origin. So A is congruent to D. And C is congruent to F. So C is 2 units away, so is F would be 2 units away, mirror images of each other, okay? So now I'm going to draw this here showing the mirror image, okay? Now what I'm going to do also is I'm going to write over here the similarities. Okay, because I know that A is similar to D, E, I'm sorry, not E, B. B is similar to E, and C is similar to F. That way you know which one goes with which because of the order in which the similar figure problem is written, okay? So now that I have that, the next thing I want to do, so it said describe the transformation. Here we have a reflection. Reflection over the y-axis. Then it says graph DEF on the XY coordinate plane, which we did. Then C here, we're going to put C graph. And then it says describe the transformation applied. So the transformation applied from triangle DEF to the larger triangle. Okay, we know that it has to be an enlargement. So in order to do that, we know there has to be a dilation because it's an enlargement. Okay, so now I want to pick 2 points that are similar. I know that D is congruent to G. So I'm going to say D is congruent to G. E, I'm not congruent, it's similar. It's similar to H. And F is similar to J. Okay. Now that we see those, the first thing I want to do is I want to just take 2 points. So I'm going to take D, which is here. D, the order pair for D is 0 or negative 4, 0. Or positive 4, 0, I'm sorry. Is positive 4, 0. And G is positive 10, 0. Okay. So it was a dilation, but I know that it's a fraction because I can't multiply just a whole number by 4 to get 10. So I have to take what I know, which I'm going to take the pre-image as my denominator and my image as my numerator, and I'm going to simplify that. So that scale factor of the image divided by the pre-image, 2 goes into this 5 times, and 2 goes into 4 2 times. Okay, so the scale factor is 5 over 2. All right, so it says select one statement that applies to the relationship. We said G, the larger triangle, GHJ, is congruent to ABC. Okay, it can't be congruent because the size and shapes are different. The shapes are the same, but the sizes are different, so it cannot be congruent. They're similar. Okay, so we know this cannot be it, so I can cross that out. It says the larger figure is similar to the smaller figure. That's true. It's similar, okay, because it has the same shape, but not the same size. Then it says the larger figure is neither congruent or similar. So we can eliminate this one, and we can circle the second one as being correct and explain the reasoning behind it is because the figures are non-rigid transformations and they have the same shape, different sizes. And it is an enlargement. Okay. All right. So let's go to number 5. All right. Number 5 says the sequence of transformations applied to a trapezoid. Which of the following statements represent a sequence where its resulting in a trapezoid is similar, but has a smaller area than the original? Select all that apply. Now, first of all, it says the result is similar, but has a smaller area. So if that's the case, I know I'm looking for a dilation that is smaller than 1, because it says that it's similar to the original, but has a smaller area than original. So if my area is smaller than original, that means it had to be reduced by a scale factor that is less than 1. Okay, So I want the ones that give me a dilation with a scale factor less than 1, okay? So let's see which ones I can eliminate. I can eliminate this one off the back because this gives me 7 over 2. 7 over 2 is the same as 2 going to 7 3 times. That's 3 1/2, okay? So I can eliminate this one. So the other thing I want to look at here, this says a scale factor 3. It's a dilation scale factor 3. That's a dilation that's greater than 1, so I can eliminate that one. Okay. Here, this says a dilation scale factor of a 1/3. Okay. That is a dilation of scale factor that is less than 1. Okay. So here it says you have a scale factor that's less than 1, followed by a reflection, and then a dilation that's a scale factor of 1/4. Okay, so it says select all that apply, which means you can have more than one answer. So the two answers that give us a sequence of transformation resulting that's similar and has a smaller area than the original, that will give us A and B. Okay. All right, let's look at number 6. Suppose a triangle has these vertices and they were dilated with the center of dilation with a scale factor 3. Which of these would be the vertex? So now I have to multiply 3 by each one of these coordinates, x and y. I'm going to do that first. Okay, so 3 times -2 is -6. 3 times 5 is 15. 3 times -1 is -3. 3 times a -3 is -9. 3 times 4 is 12. And 3 times -1 is -3. Now I want to pick all the ones that it could be. All right, which is B. It is F. And it is C. Bam. We're done. Let's go to the next one. Number 7. A sequence of transformation occurs and give you double prime. Which of the following statements are true about the sequence of transformations graphed? Okay. Now, first off, which is true about the sequence? All right, here we have our prime, original, prime, double prime. Okay. I know that I went from here to here, so I know that it is not congruent. So I can eliminate everything that's congruent. So here, take this away, which is B. It's a rotation. This is incorrect because a rotation is a congruent figure. Rotation, size, and shape doesn't change. Okay. Then it says the scale factor of the dilation is applied to produce at 1/2. So let's see. We look here. This point is -1, 2, 3, -4, +10. I'm just going to pick this one. -4, +10. And this one is -2, +5. So I know that this has been a dilation of a scale factor by 1/2. Okay. And I also know that it's a translation. Okay. Because it moved over. All right. So I know that this wasn't a rotation. I'm going back to this one because it didn't turn. Everything is in the same position. All it did was slide. Okay. So I know it's a translation. Okay. The scale factor was dilation. That's correct. By 1/2 because our image divided by my pre-image gives me 1/2, which gives me D. Then it says E, the scale factor of the dilation applied to produce A prime, B prime, C prime is 2. That is incorrect because we know it's 1/2. Okay. So the correct answers that we can pick is A because it's similar and D because it's a scale factor. It's similar because the size is the same, but the shape changes. Okay? A and D is correct. All right, let's look at number 8. All right, number 8. Two geometric figures are said to be blank if they have the same size and shape. Same size and shape say that they are congruent. And the symbol for congruent is this. Okay? Then it says two geometric figures are said to be blank if they have the same shape but not necessarily the same size. You should say similar there. And then show the symbol for similarity. Then it says blank uses a scale factor to either reduce or enlarge the original so that the figures are proportional to one another. So this is dilation. Number 11, a blank, blank, and blank are transformation that create congruent figures. For here, you should say a translation, a reflection, and a rotation. Okay, remember a translation slides, a reflection flips, and a rotation turns. Okay, let's move on. It says, based on the angle relationship criterion, are these two sets of triangles similar? How do you know? So here we see two triangles. This is 31 degrees, 31 degrees, and 70 degrees. So 70 degrees plus 31 degrees give us 101 degrees. To find C, we have to subtract this from 180. 180 minus 101 gives us 79. So C is 79 degrees. So now we look here. This is 29 degrees. 29 degrees plus 70 degrees is 99. If we subtract 180 minus 99, we're going to get 81. Okay, so we're going to say that these are not similar, okay, because of the fact, wait, that's an 81. I can't see y'all. I'm sorry. Let's go back. This is 81. So let me go back here. This is 81. 81 degrees. So 81 degrees plus 171 give us 151. And then 151 minus 80 gives us 29. Okay, which makes these two similar. So these are similar. Here, because the angle measurements are the same. Here we have 32, we have 53, we have 28 degrees, and we have 80. I can look at these numbers already and say that these are not going to be similar because all the angle measurements are different. Okay, but we can go ahead and do the math. If we add 53 plus 32, we get 85. If we subtract 85 from 180, we get 95. So angle A is 95 degrees. Here we have 80 degrees plus 28 degrees. That gives me 108 degrees. And we subtract 180 from 108 degrees, we get 72 degrees. So none of these angle measurements are the same. So these are neither similar nor congruent. So they are not similar. Because the angle measurements are different. Remember, when the angle measurements are similar, they have the same angle measures. They're not congruent, they're similar because the angle measurements do not change because the shape didn't change. The sides did, but it does not affect the angles at all. Okay, let's move on to the next one. It says, is triangle ABC similar to triangle A prime, B prime, C prime? How do you know? Okay, this is 4 units, 5 units, 8 units. This is 24 units, 12 units, and 15 units. So we're trying to compare sides, okay? So we have AB and A prime, B prime, okay? So AB is our pre-image. So we have our image divided by our pre-image, give us the scale factor. So our image is 4 units. Our pre-image is 8 units. And I know the difference. I'm sorry, pre-image is 12 units. If I simplify that, 4 goes into both. 4 goes into itself 1 time, and 4 goes into 12 3 times. So if I multiply each one of these pre-images by 1/3 and I get these, then I know it's correct. So to multiply by 1/3 is the same thing as dividing by 3. So 24 times 1/3 gives me 24 over 3, which equals 8, which is AC. AC is congruent to A prime, B prime. So that is correct. The second one, BC, is congruent to B prime, C prime. Because if I take 15, place it over 1, multiply by the scale factor 1/3, that gives me 15 over 3, which equals 5 units. Okay, so they are similar because the scale factor is true for the pre-image to the image. Okay, so yes, it is similar. All right, number 14. 14 says, what is the scale factor of the dilation? Remember, we take the image divided by the pre-image. So I'm only going to use the x coordinate. Okay, so I'm going to put 6, which is my image, over my pre-image 2. My scale factor is 3. All right, flip. Number 15. 15, Jerry is making a scale model of his lawn in order to decide where he wants to install the fountain for more landscaping. The scale model of the lean is supposed to be lawn. Sorry about that. That's a little typo. The scale factor of the lawn is shown below, and each triangle shows part of Jerry's lawn yard. Each unit in the scale model represents 3 feet. Okay? So, scale model represents 3 feet. Say which of the following statements is true about the scale model. Select 3 that apply. Lawn 3 is congruent to lawn 2. So let's look at, we're going to just take a point off of each. And because it's already on the y-axis, I'm going to pick those points because it's easier to see. Okay, so lawn 1, I'm going to take this point here, which is 0, 2. So this is 0, 2 here. The tip point here, which is a reflection, is 0, -2. And the point here is, look like 0, -5. All right, so let's go ahead and answer these questions. Lawn 3 is congruent to lawn 2. I can look at these and say they are not because they're different sizes, same shape. They're not congruent, they're similar. So I can cross that one out. The scale factor of dilation applied to lawn 3 to produce lawn 2 is 1/2. So let's look at lawn 3. Lawn 3, we can say, use the y coordinate -5. So -5 is my pre-image. It says to produce lawn 2, which is my image. So that's image divided by the pre-image. Image divided by the pre-image gives me 2/5, not 1/2. Not correct. Okay. C says lawn 2 is a reflection of lawn 1. I can literally see that. It's a reflection over the x-axis. Remember, reflection over the x stays the same, y takes on the opposite. This is true. Lawn 2 is similar to lawn 3. Absolutely, it's similar because it's the same shape, not the same size. This is true. The scale factor of the dilation applied to lawn 2 to produce lawn 3 is 2.5. Let's see. Scale factor applied to lawn 2 to produce lawn 3. So lawn 2 is my pre-image. It's producing this image. Okay, so I put the image -5 over the pre-image -2 to get the scale factor. Remember, scale factor is image divided by pre-image. So that gives me 5 over 2, which simplifies. 2 goes into 5 2 times with a remainder of 1 over 2. 2 1/2 is equivalent to 2.5. So this is also true. Okay. Let's look at 16. 16, Ryan drew a rectangle ABCD on the grid. Ryan translated it 1 unit right and 1 unit down, then reflected across the x-axis. What are the new coordinates? Okay. First, I'm going to take this, I'm going to write this as coordinate notation. So 1 unit right is x plus 1, and 1 unit down is y minus 1. So that's x plus 1, y minus 1. Then it says, then it reflects it across the x-axis. If I reflect it across the x, remember the x stays the same. Y takes on the opposite value. So now let's look at these points. It's only asking you for the new coordinates of A double prime. So all I need is A first. A is -5, +4. I'm going to add 1 to it and then subtract 1. Okay, 1 unit right, 1 unit down. So add 1, then subtract 1, and I get A prime. -5 plus 1 is -4. 4 minus 1 is 3. I can also do it on my grid. Go 1 unit right, 1 unit down, you're here for A prime. And again, it's -4, +3. Then it says you're going to reflect it over the x-axis. That means the x stays the same, y takes on the opposite. So A double prime, which we're going to do it here, x stays the same, y takes on the opposite. Opposite of a +3 is a -3. So I can reflect it. I'm going to go 1, 2, 3 from the line of reflection, 1, 2, 3 from the line of reflection, and that's my A double prime. And again, the order pair is -4, -3. Okay. Let's look at number 17. 17 says, rectangle ABCD is plotted on a coordinate plane. It is reflected across the x-axis, then dilated by a scale factor of 1/2 to get the image. What is the relationship between these two figures? It's reflected across the x, which means that's rigid, but then it's dilated, which means it's similar. So I can get rid of congruent, okay? They are similar. I can say yes because they are similar figures because you had a reflection by dilation. They have to be similar, okay? They are no longer related after these transformations. That is incorrect because they are similar. It is not possible to determine a relationship given. That's wrong. Okay, so they are similar. All right, let's look at 18. 18 says, rectangle ABCD is shown. What is the measure of x? Okay, I know that this triangle is 180 degrees, all of the angles, but I'm missing an angle, okay? I know that this line is parallel to this line. I can consider this a cut by a transversal, okay? So I'm going to look here, and I look at alternate exterior angles, okay? I know alternate interior, so this angle here is congruent to this angle here, okay? They're alternate interior. So this is 55 degrees, okay? Because this is 55 degrees and this is 80, I add these two together, which is 55 plus 80. I add that up, I get 135. I subtract that 135 minus 180, and I get 45 degrees. So angle X is 45 degrees, okay? You could have also added up these two, 80 and 55, and get 135. All three of these share lines, so it's supplementary, which means when you add these together, they should equal 180 degrees. So you find this missing angle by subtracting from 180 is 45 degrees. And these two are alternate interior as well, so they're congruent that way also. Okay. All right, let's look at number 19. It says triangle ABC is similar to triangle XYZ. The triangles are shown. What is the scale factor? So the scale factor here, I'm showing that this side is similar to this side. So this shows 2, and this shows 4 units. This is 2 units. This is my pre-image. This is my image. So my scale factor, I'm going from a small to a large number. Image is 4. The rest of the sentences here, I'm sorry that it cut off. Image divided by pre-image is 2. So my scale factor is 2. Explain how to determine your answer. We divided the image by the pre-image. Remember, we count the units that give us the scale factor. So here was 2 units and here was 4 units. All right. It says write the sequence of transformation that exhibits the similarity between the two triangles. Okay. Here we says the measure of angle C is 49. So this is 49 degrees. So the other one that has 2 lines is 49, which is F. G is 56 degrees. So G is over here. It's 56 degrees. It has 1, 2, 3 lines. So the other one that has 3 lines is E. So this is also 56 degrees. It said, what's the measure of H? So I know that these have to be similar. Okay. So in order to do that, I have to add both of these together and then subtract it from 180. So 49 degrees plus 56 degrees, that equals 105 degrees. And then subtract that from 180 degrees, that gives me 75 degrees. So the measure of angle H is 75 degrees, which is also congruent to D if they ask. Okay. 21, given measure of angle D is 42 degrees. F is 83 degrees. What is the measure of E? So we're looking for E. So F is 1, 2 lines to show similarity. So that means it's congruent to C, which also has 2 lines, which is 83. So to find E, I'm going to add these 2 together and then subtract it from 180. So 83 degrees plus 42 degrees equals 5, 12, 125 degrees. Then subtract 125 minus 180. And that gives me 55 degrees. Okay, so E is 55 degrees. Here I know that G has 1, 2, 3, which is also similar to E. So this is also 55 degrees, which makes H similar to D, which is 42 degrees. All right. 22. 22 says, find the measure of P. Present an informal argument to show your reasoning. This is an external angle. This external angle equals the sum of the 2 internal angles. So 35 degrees plus 32 degrees equals 67 degrees, which equals the measure of angle P. Okay. Angle Q. These are supplementary. Okay. But these 2 angles add up to equal 155. So if I take angle Q, which I'm trying to find the measure of, and add it to 128 degrees, it should equal 155 degrees. So I'm going to subtract 128 degrees from both sides, and that'll give me the measure of angle Q. All right, so Q equals, borrow from here, that gives me a 4. Carry that. 8 minus 15 is 7. 2 from 4 is 2. So Q is 27 degrees. And 24. 24 shows, wants the measure of angle R. If I add B and A together, I'll get the measure of angle R. So I have R equals 103 degrees plus 18 degrees. Therefore, R equals 121 degrees. Okay? Because this is an external angle, it equals the two internal angles. Okay? You could also add these up and subtract it from 180. And because these two are supplementary, this angle and this angle, you'll subtract it from 180 to find this missing angle. Which, if you just add these two together, you'll get that one. Okay? And the last one, which is 25. 25 says line L and M are parallel, which is important because you can't, none of this will work if the lines are not parallel. It says line QR, which is here, is perpendicular. Perpendicular lets you know that this forms a right angle. So I'm going to draw a little square here to indicate a right angle. And I know that a right angle equals 90 degrees. Okay? So I have 90 degrees is angle 4. That's a giveaway because it says it's perpendicular. And then I know that angle 48 and angle 2 are alternate interior because they're inside the parallel lines. And this is a transversal here. When you have two parallel lines cut by a transversal, then you have alternate interior angles. So the measure of angle 2 is congruent to the measure of 48 degrees. So this is 48 degrees here as well. Okay. And I know that these two angles are adjacent angles and they're supplementary. So the measure of angle 3 plus the measure of angle 2 equals 180 degrees because they're supplementary. So if I know the measure of angle 2 is 48, and I need to find the measure of angle 3, I need to subtract that from 180 degrees. So I'm going to subtract 48 degrees. So the measure of angle 3 equals 180 minus 48. So I'm going to borrow from here. This becomes a 7. This becomes a 1. That's a 2, a 3, and a 1. So the measure of angle 3 is 132 degrees. Now I need to find the measure of angle 1. I know that the measure of angle 1 is the difference of 48 and 90 when it's subtracted from 180. So I can add these two together and get the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 equals 180 degrees. Because I know the measure of angle 4 is 90, I'm going to substitute 90 degrees here. The measure of angle 2 is 48, so I'm going to substitute that there. But I'm still trying to find the measure of angle 1. And all that equals 180 degrees. When I combine like terms, I have 48 and 90. That gives me 138. So the measure of angle 1 plus 138 degrees equals 180 degrees. Now I'm going to subtract 138 from both sides. And I have the measure of angle 1 equals, borrow, this becomes a 7, this becomes a 1, so it gives me a 2 here, and then a 4 here. So the measure of angle 1 is 42 degrees. All right, let me know if you have any questions, and good luck on your exam.